Hello everyone, welcome to our next lecture of our radical chemistry course. So this is the class 5. So in this particular lecture we are talking about the radical reactions. Like in previous lecture we are discussing about the how to generate a radical, what is the stabilizing factor of a radical. So this particular lecture we are actually dealing with the radical based reactions. And this part are very important in terms of exam purpose as well as the radical chemistry part. Okay, so first let us understand that how a radical react. Radical can be reacted by the three possible ways. Like first, two radical combined to generate a spin paired molecule. Like here, two bromine radical are combined each other to generate a Br2, that is a spin paired molecule. Also, there is another possibility is there is a one radical and one spin paired molecule is there. So one radical attack with the one spin paired molecule to generate a new radical and a new spin paired molecule. That means here this is the OR radical react with this particular spin paired molecule to generate this particular alcohol plus this R2 is the new radical. And also there is another possibility is radical will undergo rearrangement decarboxylation pathway to generate a new radical and a spin paired molecule. Like here, this is the acetate radical. Here, this particular radical will undergo spin dissociation, decarboxylation, and then this particular R radical has a new form, and the spin paired molecule, this carbon dioxide, has been generated. Now, a radical can be reacted by the combination of this pathway. So, a normal radical reaction can be done by three different steps. First is the radical initiation, second is the propagation, and third is the termination. The initiation step is the generation of radical. That is, this particular radical can be this particular bond has been cleaved to generate this radical. Now, this particular bond can be cleaved by using a initiator when a thermal method has been used to generate the radical. Also, it can be photochemically dissociated or the presence of light. This particular bond dissociate to generate these two particular radicals. Now, this generated radical can react with other molecule, especially the other spin paired molecule, to sustain the chain reaction. Now, this chain reaction can be done by a two different pathway. One is the radical addition and the radical transfer. Like here, this A radical that is generated here by the initiation process, this will react with the spin paired molecule to generate a new compound, is the AC, and D radical is formed. So here the A radical can be transferred or can be changed to a D radical. So there is a radical transfer is also there. Now, and this particular D radical will again attack with the one any spin pair molecule and this chain reaction continues. Now to end this particular chain reaction, there is a termination process. Like at the end, radical are consumed or quenched. That denotes the ending of the particular reaction. Now, it can be happen in the two different pathway. One is the radical combination, where these two different radicals are combined to generate a spin paired molecule, or radical can be disproportionate, like in presence of solvent and all, radical can be taken or the proton from the solvent to generate this particular compound and the reaction getting quenched. So this is the very basic pathway of any kind of radical reactions. Now let us talking about the radical chemistry chain reactions. Like this type of reaction is very important in the exam point of view. Like here, this is the alkane group is there. Like if for the bromination of this particular alkane group, then what happened that in presence of HBr and this is the peroxide in presence of photochemical pathway, we get this bromine bromine addition has been observed. Now here if we look about the mechanism of this particular reaction, then we can say that initially this particular peroxide compound acts as an initiator where this will photochemically dissociate to form this particular RO radical. This RO radical react with the HBr compound to generate our targeting radical, that is the bromine radical. Now this bromine radical will react, this is the propagation step, this bromine radical will react here to generate this new radical, and this new radical will again quench with the other HBr molecule present in the solution to generate our this particular compound. Now if we check carefully, then bromine can't attack from this side. If bromine radical attack from this side, there the primary radical formation has been observed. But here, if the bromine attack here, then the tertiary radical formation is observed. That means, and if we see that this particular compound getting major, that means that particular bromine can attack here to generate this tertiary radical, which is the much stable over primary radical. That means the selectivity of the reaction is solely depend on the resultant alkyl radical stability. Like this particular radical is much stable over the primary radical. That's why this particular compound has been formed, and this compound is not formed. This is not major. This was the major compound has been generated, because if this particular compound has been generated, then the radical will be a primary one. Okay, and this is not a stable radical. That's why we can say that the stability selectivity is solely depend on the alkyl radical resulting alkane radical stability. Okay, now let us talking about the chlorination of cyclohexane. Like here cyclohexane, where the chlorine in presence of photochemical condition, the monochlorination has been observed, and the byproduct we got the HCl. So the step is the initiation first. Like the chlorine can be photochemically cleaved, or the homolytic cleavage has been observed to generate the chlorine radical. Now this chlorine radical will take the hydrogen from here to generate this particular secondary radical, and this secondary radical is now attack a fresh chlorine molecule to generate our resulting compound, the hexane, 1-chlorocyclohexane compound. Okay, and this particular chlorine radical is again go here to continue the chain reaction. Okay, now after doing the reaction, there is a termination step is there. The termination can be done via two different pathway, like either this particular chlorine radical will react with another particular chlorine radical to generate the Cl2 back. This will be the one termination process, or this radical, the resulting the secondary radical will react with the single chlorine radical, and then this particular compound has been generated, and thus the termination has been observed. And here the important thing is bromination is more selective than chlorination reactions, and we can prove this particular statement in our next slide example. Like here in this particular compound, if NBS and CCl4 is used, then allylic bromination has been observed, and this particular compound become a major one. But when the direct bromination has been used in presence of photochemical condition, then 1,2-dibromocyclohexane become the major product. So why this is happening? Basically what happened that NBS is a low concentration source of bromine radical. So since the bromine radical concentration is low, then what happened that this particular hydrogens having the lesser bond dissociation energy, because the resulting radical is the allylic radical which is stable. So what happened, this particular bromine radical will take this particular hydrogen, and this particular radical has formed, and now this particular radical will go a termination step where the bromine less concentrated bromine radical will react with this particular radical to generate this allylic bromine compound, and this becomes the major. But in the case of Br2, here the bromine radicals present in the higher concentration. So what happened that if we draw here the particular compound, little bit something like here, Okay, so what happened that initial the bromine radical will attack here, directly attack in the double bond, and this particular compound has generated. This particular radical has generated, and this particular generator now go in a termination step where the other bromine radical will combine to generate this particular compound as a major compound. Due to the higher concentration, we got this type of selectivity, and in the case of lower bromine concentration, we got this type of selectivity. So let us talk about some kind of examples. Like here in this particular compound, since there is a NBS-CCl4 is there, that means the low concentration of Br radical is present here. Thus, the allylic product become the major one. And after treating with the H2 and K2CO3, this bromine is replaced by the OH group, and this is our final product. Similarly, in our next example, here the NOCl in H nu, it generate this type of radical and then undergo rearrangement to get this type of compound. And after that, in presence of acidic condition, a Beckmann rearrangement has been observed to generate this type of compound. Okay, so with this we have to end this particular class. So in this particular lecture we are learn that how radical can react. There is a different step of radical reactions, and after that we are talking about the bromination of chlorination or the chain reaction of a radical. So in the next class it's a very important class where we are discussing about the tin hydride mediated radical reactions. So thank you for listening this particular class. So we'll meet on next class.